All right, so we are back at it, and today what we're going to do is put together a couple of things that we've talked about in our last couple of lessons with simplifying rational expressions with multiplication and division, addition and subtraction. We're going to use all of that to solve rational equations. All right, now the reality is you've already been solving rational equations for a few years. Whether or not you realize that or not, you have been. Because if you look at the opener, all right, in parts A and B here, these are rational equations, and my guess is most of you, if not all of you, have solved many, many different equations that look very similar to these two equations. So, to get us started, all right, why don't you pause the video, solve, all right, the rational equation in A and B, known as a proportion, all right, which many of you have solved already before. Use whatever method, all right, or technique you want to do, and then we'll talk a little bit about maybe a couple different ways at solving. So go ahead and pause the video and solve A and B there. All right, so here's what I'm betting most of you did here. All right, I'm going to show the answers right here. My guess is most of you did what we call cross multiplication, where you did 4 times x plus 2 equals 3 times 8. All right, and then you went through and solved this like a regular linear equation, and you got x equals 4. And then probably very similar fashion over here, 12 times 2x minus 1 and 4 times 2x minus 7. And then you solve that and you get x equals 5. So my guess is that's where most of you, or what most of you did when you solved those two equations, all right, and that's probably what you've done throughout the years to solve those. Now, a couple of different things. So first, are there any domain issues with either of the problems in the opener? All right, and so when we look at this one, there are no issues, right? So we have two constants in our denominator, so we don't have to worry about either one ever being 0, versus B here, we have this factor, right? So we know, right, that 2x minus 1 can't be 0, which means 2x can't be 1, which means x can't be 1/2. So we know that, all right, in part B here, our domain, right, would be all real numbers except x can't equal to 1/2. All right, and so we find those domain issues for rational equations the same way we've been finding domain issues for all the rational functions that we've talked about, right? So any values that make our denominator 0 in the very beginning of the problem, we have to throw out. All right, so this may be something that you've not considered before when you solved a proportion in this manner. Now, what are you really doing when you solve these problems? So when you cross multiply, what are you really doing? And so I'm going to pull these problems back up on the blank page here and show you what's really happening when, all right, you are cross multiplying. So what the reality is you're doing is that you're really multiplying the entire equation by your common denominator. All right, so for example, when I look here, 4 and 8, if I had to get a common denominator, all right, it would be 8 on both sides. So notice, all right, what I could do here is I could multiply everything by 8 here. All right, and so when I did this, I would have 8 times this, right, and that would be 3/4 times 8 equals, and then I would do 8 x plus 2 over 8 times 8 here. All right, and so notice what I get here is 24 over 4, which would reduce to, right, all right, 6. And then over here, right, I'd have 8 times x plus 2 over 8 like that. And so notice 8 divided by 8 is 1. 24 divided by 4 is 6, so I get 6 equals x plus 2. And I could just subtract that 2, and I get 4 is equal to x, which was the same number, that solution that you got just a moment ago. All right, so that's really what's happening. You can see it a little bit more over here when we notice if we multiply by the common denominator here, which would have been 27 times 2x minus 1. So notice if I were to multiply everything by that common denominator. So when I multiply 27 2x minus 1 times the left side here equals, right, 12 over 27, all right, and I get 27 times 2x minus 1 here on this, and remember that's all over 1. That's all over 1. And notice what happens here, right? We see those common factors, and that leaves me 27 times 4, right? And then I get 27 here, and then I get 12 times 2x minus 1 here. And so notice this is the line you get when you cross multiply. And that's why cross multiplication works, because it's really just a simplified version of multiplying by the common denominator of the left side and the right side of a rational equation. All right? And so that's what's happening, and that's why this step works every time when you cross multiply. All right? So that's one of the things that we need to think about. And that's actually going to come in very handy because some of our rational equations are going to be a little bit more complex than parts A and B. Now, if it's still a proportion, you can solve it by cross multiplying. But we're going to focus on this idea right here about multiplying, right, by our common denominator. Okay, so now let's look at some steps here. Now, once again, just like we've been doing before, right, we're going to factor those denominators completely, right, because we have to throw out any values of x that make our denominator 0. All right, so we want to throw those out right away. All right, and that'll help us state those domain restrictions. Now, we're going to find the least common denominator. All right, so we're going to go back to what we were doing in our previous lesson with adding and subtracting, right? We had to find those common denominators. Then we're going to multiply both sides of the equation by that common denominator. So now we're going to get into the lesson before the prior lesson, which was those multiplying ideas. Then we're going to solve. All right, and then we just need to compare the solutions we get against those domain restrictions. All right, so if I go back to what we said here, right, we said, okay, the domain, I can't use 1/2. So had I solved this equation and gotten a value of 1/2 for x, I would have had to throw it out and said, okay, there's no solution. All right, so once we solve our equation, we then have to compare it to those domain restrictions and make sure we don't get any values that do not work. All right, so let's take a look at, all right, some problems here. All right, so let's take a look at number 1. Now, once again, when we look at number 1 here, this is a proportion, right? This is something that you know how to solve. So if you want, all right, you can just use what you already know. But the one thing we want to do now is consider the domain, right? So notice here, I don't have to worry about any domain issues here. I look over here, all right, I have one factor that I need to work with. Notice I don't have to factor it here. It's already a linear factor. So I know, all right, I know, and I'll just do it down here, that 3x plus 4 can equal to 0, which means 3x can equal to -4, which means x can equal to -4/3. So the only value of x that I cannot get as a solution, all right, would be that -4/3. All right, so if I solve this and get any other value besides -4/3, I'm good. All right, so once again, if we do this, we can cross multiply, and so I would get 4 times 3x plus 4 equals 7 times 16. And notice that would give me 12x plus 16 equals to 112. And then we just get into our solving process, right? Subtract 16, subtract 16. So 12x equals 296. And then I can divide by 12, and I get x equals 8. All right, so notice now I get x equals 8. That doesn't conflict with the values I had to throw out, so I'm good to go there. So my solution would just be x equals 8. Now, once again, if you want to double check, right, we can go back and plug 8 in here, all right, and I can reduce that fraction, and it should give me 4/7, or the equivalent of 4/7 if you do it as a decimal. All right, so that's the normal rational equation that you have been solving for a few years now. All right, so now let's look at number 2. All right, so this is where it gets a little bit more complicated, because now when I look at number 2, all right, so notice now I can definitely see that I need to do some factoring, all right, in, all right, my denominator here on the left side. So once again, I'm not going to show my factoring process, so if you need to pause the video to do your factoring process, do that. Turn it back on to see if you match what I have. So when I factor x squared minus ax minus 20, all right, the only way to factor x squared is x times x. And so I need the factors of -20 that add to be -8, which would be -10 and +2. Now on the right-hand side here, no need to factor. I have my linear factor there. There's no GCF there either, so I'm good to go. All right, so now when I think about, all right, the left side versus the right side, I can see that both denominators contain x minus 10. All right, so that's definitely going to be part of our common denominator. It's going to be something that I need to multiply by. So I definitely need to multiply by x minus 10. Now if I look, this denominator has x plus 2. This denominator doesn't. So I need to include that. I have to make that part of my common denominator. So that's now going to be my second piece here. All right. So now, once I find that common denominator, right, and now what I want to do is distribute this common denominator to everything on the left side and everything on the right side. So notice x minus 10 times x plus 2 times the left side is just going to leave me 16. All right? Because the x minus 10 over x minus 10 is 1. X plus 2 over x plus 2 is 1. Okay? And then equals 2. Now, when I distribute on the right-hand side here, x minus 10 times x minus 10, that's 1. But then I'm going to be left with this 4 times x plus 2. All right? So now, once again, notice once I've distributed with that common denominator, all right, it becomes just a regular linear problem, right? So 16 equals, and I get 4x plus 8. Subtract 8, subtract 8. 8 equals 4x, all right, which means x has to equal to 2. So that's my solution. Now, what I forgot to do is once I factored up here, I forgot to look at my denominators to throw out my value. So let's do that real quick with our domain. So, all right, so when I look at my factor here, x can't be 10. All right, so x can't be 10. When I look at my factor here, x can't be negative 2. So notice my solution of 2 here, all right, does not conflict with any of the values I had to throw out, so that is a good solution. All right. So let's take a look at the next problem here. Let's look at number 3. All right. So now when I look at number 3, once again, left side, factored, no big deal. So I'm just going to bring that down. Now I'm going to factor my right side. All right, so 4 over, and then I have this guy, so x, x. All right, so now I need the factors of 12 that add to be negative 8. So that would be negative 6 and negative 2. All right, this time I'm going to take my time. All right, not forget to check my domain restrictions. So when I look here, I know that for that factor, x can't be 2. When I look here, that factor, x can't be 6. So there are my two values I have to throw out. Now I want to think about creating a common denominator, all right, and multiplying through by that. So what I can see is x minus 2 is common to both denominators, so I definitely need to include that. All right. I can see that x minus 6 is in this denominator, so I would need to also include it in this denominator. So x minus 2 times x minus 6 would be my least common denominator. Excuse me. All right, so now that's what I'm going to multiply through by. So notice here I do x minus 2 times, over x minus 2 here, so that's 1. So notice that's going to leave me x times x minus 6 equals, and then x minus 2 divided by x minus 2 is 1. X minus 6 divided by x minus 6 is 1. That's going to leave me 4. All right, so notice what I get here. All right, I get x squared minus 6x equals to 4. So notice sometimes when we do this process, we get a quadratic result instead of a linear result. All right, so now that means the first thing I want to do is set this equal to 0, because anytime we have a quadratic equation, we have to have it equal to 0. And I get to this step. So now, once we get to this step, now you have all your tools for solving a quadratic equation. So you can factor it, you can do quadratic formula, maybe solve by square roots, depending what's left in the problem. And so in this case, when I look at this, I would need the factors of negative 4 that add to be negative 6. Well, in this case, there are no factors of negative 4 that add to be negative 6, right? Because it's either 3 times negative 1, which would be, all right, 2, or negative 3 times 1, which would be negative 2. So there's no possibility of factoring to get to this combination, which means we now have to use the quadratic formula. All right, so x equals the opposite of b, plus or minus the square root b squared minus 4ac all over 2a. All right, so now if we simplify all of this, we get x equals 6 plus or minus the square root of 52 over 2. All right, and if I'm looking to reduce here, all right, so I think that is 4 times 13, so that would be 6 plus or minus 2 root 13 over 2. All right, and then now I can see that there's a 2 common to everything. So I can divide all 3 terms by 2, which would give me 3 plus or minus the square root of 13 as my solution. And you could put it over 1 if you want. All right, and so there's my answer. So you have to be prepared that you could either have a linear equation like we saw here in number 2, or the possibility that once you multiply through by your least common denominator, all right, you might end up with a quadratic equation. So now we can see that my solution, 3 plus or minus the square root of 13, is just like that. All right, we're going to do one more together. Let's do number 4 together. Just because I wanted you to see one where we have more than, all right, 2 terms. All right, so now we have 3 terms in this equation. Now, the process is the same. So the first thing we want to do is factor. All right, so when I look at the left denominator here, I have a GCF of 3x. So I'm going to factor that guy out. And that gives me x plus 6 equals, and I get this 5x minus 15 here. Once again, I can see I have the same GCF in the second denominator here, so I'm going to factor that 3x out. All right, I'm going to get x plus 6 plus, and then in my last denominator on the right-hand side, I have just a GCF of x. All right, and that leaves me x plus 6. All right, so I have lots of pieces here. Now remember, when we're thinking about a common denominator, I have to look at everything. All right, so when I look, the first thing I see when I look at all three denominators, I'm going to take everything that is in common to those three denominators. All right, so when I think about what's in common to all three denominators, I can see that there's an x in all three denominators, so that's definitely going to be part of my common denominator. All right, I see x plus 6 is common to all of my denominators. Now, notice the 3 is in this denominator. The 3 is in this denominator, so I would need to multiply by 3 as well because I would want it to eventually be in that denominator when I think about trying to come up with my common denominator. All right, and so there's my least common denominator, 3x times x plus 6. And so that's what I'm going to multiply through by. Now, the process doesn't change, it just becomes a little bit more complex because notice now I have to multiply that times all three terms. So if I distribute this times the fraction on the left, notice everything's going to divide out to be 1 and going to leave me the 2. Notice when I distribute this times this fraction, once again, all of this is going to divide to be 1 here. It's going to leave me 5x minus 15. And then when I distribute this times this fraction, the x divided by x is 1, the x plus 6 divided by x plus 6 is 1, and that's going to leave me just 1 times 3, which would be 3. So notice now I get to this fairly easy, so 5x minus 12 here, all right, fairly easy to solve linear equation even though it was a little bit more complex looking in the beginning. All right, and so I can add 12 to both sides. All right, so 14 equals 5x, divide by 5, right, and 14/5 is equal to x. All right, okay, and we would go from there. All right. Okay, so when we think about that particular problem, all right, and you can make that a decimal if you want, so I think that would be 2.8 if you wanted to write it as a decimal. All right, so that would be our solution. Now, once again, I got in a hurry. I didn't write down my domain issues. Let's do that real quick. All right, so 3's, I don't have to worry about. 3 can never be 0. So that's okay. So now, for this factor, x can't be 0. And for this factor, x can't be negative 6. And then my solution would be 2.8. All right, so there it is, my friends. So that's how we solve rational equations. We'll do a little bit more practice in class. All right, be sure to do your video check-in, and I will see you for our next lesson.